Hey, hey, hope you guys had a fantastic weekend. We are to day one, part two. On page three, here you see, of chapter six. So, we had a chance this chapter to introduce ratios and proportions, and we're actually going to throw this back a little bit to some previous geometric concepts as we use a graph to write ratios. And here's the thing, guys, we know that ratios always need to be written in simplest form. So I look at number six. We've got A to B. That right there, that looks like it is a distance of 4 over B to D. That is a distance from 0 to 7. So 4 over 7 will be our ratio there. How about EC to BC? Well, EC is straight down. Looks like that is 6 high over BC, which is 4. But again, we don't want to leave it like this. We want to reduce this. And it reduces down to 3 over 2. All right. Number 8. The slope of BE over the slope of AE. Now, this one's interesting. Actually, I'm going to bring this one down. And I want to see what you guys can do, because this one's going to be interesting. We're actually going to have a fraction divided by a fraction. So, slope of BE, this line right here. So what would the slope of that line be? Well, we go rise over run. Looks like we go up 6 over 4. So 6 over 4 divided by the slope of AE. Ooh, so this line's even longer. Looks like it is going to be up 6 and then over 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, guys, do you remember how to divide fractions? Do you remember how we do this? We got a little saying we use. Huh? Hopefully you remember. It is keep, change, flip. So in other words, we take our first fraction and we keep it the same, 6 over 4. We change the division to multiplication, and then we flip the second fraction. And so we multiply 6 times 8, 48 over 4 times 6, 24. And when you reduce that fraction down, that's really 48 divided by 24 is really 2. And then I'm going to let you guys try number 9. How would you describe EC? So EC will be this right here. How would you describe EC? Is it an altitude or a perpendicular bisector? Well, a bisector would mean cut in half. So from 4 to 7, that is a distance of 3. And on this other side, from B to C, ooh, that's a distance of 4. So these are not the same. So if it does not cut these in half, but it does drop down, straight down to create right angles, we know we get an altitude, a tude. All right, and then the last one on this page, guys. We know we're going to use a proportion to solve this problem. And so, listen, if we know we're going to use a proportion to solve, I already know there's going to be some cross multiplying going on. You can guarantee. So take a moment, guys, to read. Go ahead and read this problem for me. So let's break it down here, guys. We got somebody who's making bronze sculptures of dogs. They must be a big fan. The ratio of the height of a sculpture to the actual height of the dog. Okay, so we're going sculpture as it compares to actual. That's the order here. And we're told that the ratio is going to be 2 to 3. Okay? We're also told the height of the sculpture is 14 inches. But we don't know the height in inches of the actual dog. We know the ratio and we know the height of the sculptures, but we don't know the actual. So what we can say is we can say that we know our first fraction is going to be 2/3. That's the ratio, 2/3. And then we can compare it to, as far as actual height proportion is concerned, 14 inches pairs with 2. And we don't know the actual height of the dog, so we will call that X. And so like I said, guys, you know exactly what to do. We're going to cross multiply. 3 times 14 is 42. 2 times X is 2X. And when you divide by 2, you find out the actual dog is 21 inches tall. All right, on to the last problems of the day, guys. Page 4. So, page 4, and you can see a little heads up, a little foreshadowing here. Chapter 6 quiz. It is primarily going to come from day 1, and it's going to involve ratio and proportions, which is what we've talked about pretty much this entire day. So you can already see what's going to be coming from our quiz. It's going to be from day 1. Now we're going to end with something a little bit different, guys. We're going to end with something called a two-way probability table. You will see these a lot on the ACT as well as in Algebra 2. These are very popular in both. And usually they involve us stating probabilities based off an experiment. So based off, studies actually done. Think of this almost as experimental probability, what we talked about at the beginning of the year. So for example, they're going to give you 2 different categories. In this case, we've got how many people are riding mountain bikes, how many people are riding road bikes, and when they ride them. Rides to work, does not ride to work, and then here's our total. And we can see, first and foremost, 100 total people. 100 total people were interviewed for this, guys. And we can see there are 30 people that own road bikes and 70 people that own mountain bikes. 30 people that ride to work, 70 people do not ride to work. Guys, this is coincidental. This column and this column, it's just random that they're the same. These are not connected. It's just a crazy coincidence. So, first off, what's the probability, P, that a person randomly selected owns a mountain bike? So just straight up, what are the chances that we pick somebody out of this group that own a mountain bike? Well, we're choosing out of all 100 people. That's our sample size. And we know that looks like 70 people own a mountain bike, which can reduce down to 7/10 or 0.7 or 70%. Any of these 3 could all work. Any of those 3 could work. So I'm going to let you guys try. You can go ahead and pause the video and try number 2 for me, please. Well, does not ride to work. Looks like that's this whole column, which is 70 total people out of all 100. And I cannot stress this enough, guys. These not connected. That and that are not connected. It is just completely random. Completely random. And we know that reduces down to 7 out of 10. Now, guys, here's where this gets a little bit trickier. Numbers 3 and numbers 4 have to do with what's called conditional probability. And what I mean by that is we are not looking at all people. We are not looking at all the people. You know how here we were looking at all 100 and here we were looking at all 100? Check this out. Number 3. What is the probability that a person randomly selected from this sample does not ride their bike to work? Okay, just like last time, does not ride their bike to work. But hold the phone, given that they own a mountain bike. So guys, just like before, what's the chances of us not that they don't ride their bike to work? Given that, we use a slash to represent given that they own a mountain bike. So are we looking at everybody now? Are we looking at 100 people? No. We are only looking at people who own a mountain bike. So that's going to affect our denominator, because this is all the people we're looking at. So how many people own a mountain bike? 70 people. So out of the 70 people that own a mountain bike, how many do not ride those to work? So mountain bike, out of these 70, 58 of those people out of these 70 do not ride it to work. See that? Which I believe you can divide both by 2, reduces that down to 29 over 35. So we limited how many people we were looking at in our total. I'm going to let you guys try number 4. Really give this one a good shot here, guys. Go ahead and pause the video, and when you're ready, you can unpause it. All right. So again, we look at what we're given first. That's going to tell us what our sample size is. So how many people do ride their bike to work? Looks like that's only 30 people. Now, out of these 30 people, how many ride mountain bikes to work? Which sounds really weird. Looks like only 12 out of the 30, which reduces down to, you can divide these both by 6, 2 over 5. So excellent work, guys. Knocked out this day. Great start to the week. Our homework is going to be the practice multiple choice. So thank you very much. If you have any questions or you need a chapter 6, reach out to me and I can meet you out front by the flagpole and get it to you. Thank you, guys.